try to find the x, you said it equal to 0.
Which one are you on?
That's second one.
No, I just use what you know about mx plus b form.
I can't remember. Maybe it's I know it.
I'm such a good brain here, Coach Wright. It's like a miracle.
What'd you come up with? You're not gonna tell me?
I got one for Maya Angela.
She's good. That's good. I like it.
Thank you.
What is it?
It's from Maya Angela. It's not funny.
Let me see.
It's inspirational.
It is.
I don't know.
I have written some on the back, but I'm just gonna go with that one.
Good job. So sorry. Is this right?
Maybe it's 0.
It's supposed to be dotted lines, right?
I'm gonna have one dotted line.
This way?
Okay, let's go ahead and look at what you got. So the first thing I would do, and it's been a minute since we did piecewise, that's why I brought it back up, because it's gonna be on your test next week. Okay, so first thing I did was dotted my boundary line. I got my boundary line from the if stuff. Just screwed it up a little bit so everybody can see it good. The if said, x is less than 3 or x is greater or equal to 3, so I dotted my line at x is 3. Okay, now this first piece is a v because it's an absolute value function. It's in vertex form, so I know it has a vertex of 1, -5. So I'll go over 1 and down 5, and there is the vertex, okay? But look here, it tells me to show the part to the left of my dotted line. Well, that's good, because I'm already to the left of my dotted line, right? What is my A out here in front of the bars? 1, so that means it's going to have a slope of 1 on a V. So rise 1, run 1. Rise 1, run 1. You're going to have your V. You can't cross that dotted line, so I'm going to stop on it and put an open circle on it. But then it'll go for, it'll go for ever in that direction. So it kind of looks like a backwards check mark, right? Okay. Okay, now to my
question. Why did you do this? Why is there only 2 dots or 3 lines up there?
3 lines where?
Why is it plotted on the 2? Oh, it's plotted on the 1.
Because the vertex was 1, -5. Yeah. Alright, so now my second equation is in slope-intercept form, mx plus b, so it's b is 7. So I'm going to go up to 7 and put a dot. 1, 2, 3, 4, 5, 6, 7. And then from there, its slope is -2. So I'm going to go down 2 and over 1. Okay, but this one wants me to show the part to the right of my dotted line. So I got to go down 2 and over 1 again. Then I got to go down 2 and over 1 again. It gets colored in there because it's equal. So there's a line, but I'm not going to connect those points because they're on the wrong side of my dotted line. So go down 2 over 1 again. Here goes my dotted line, my second piece. So we got to check.
Is it a dotted line?
Say what?
Is it a dotted line?
Nope. It's a check mark and a solid line.
We were close.
Yeah, y'all weren't horrible on that.
I thought you said 1 was going to be dotted.
My x equals 3 line is dotted.
Oh, x is greater than or equal?
Mm-hmm. Ah,
This one, so this one.
that's a solid line. There's nothing, there's not, the function right here, Riley, look at this part, this is what decides. This says equal, so everything's solid. If that had a less than or a greater than, that's when you'd be worried about dotting.
So this is right.
Alright, now we gotta talk about domain and range it asks for. Okay, so domain, this one's gonna go to the right forever. This one's gonna go to the left forever. So the only point in question is the one on our boundary line, and yeah, the line touches it, so my domain on this one would be all real numbers. Okay, range, this one's gonna go down forever. This one's gonna go up forever. So does it hit everything up and down?
Yes.
Yes, so range is also all real numbers. Alright, while you were working on that, I passed out to you another little organizer note sheet to go over end behavior, so get that out and we're gonna go over that together and fill that in. Didn't give you one. Oh, I will now. Sorry about that.
Miss Ray, how you skipped it?
I don't know. I know it was here. Alright. Come on, Riley, need you to get over here and get with us. Get those telephonos, sir. I'm taking them. Jeez Louise. I know, time's flying. It's gonna be Thanksgiving for you, huh? Yep. Okay, so in behavior, that means where the arrows are on your graph. So when you see in behavior, they're asking about what it's doing the farther away from you it goes. Because you know those arrows on a line or on a V or on a U means it keeps going. So that's what we're going to be talking about. So first off, let's start here with linear. I hope this thing lets me write here. That would be great. Sometimes it's ornery and doesn't let me. Let's see what happens. Linear's parent. This is parent function. F of x equals x. That's a line, right? Y'all are good. We remember that. Okay.
I needed this sheet.
Now, do you remember what the graph of f of x equals x looks like? It is a line. It is a line. Okay, it doesn't have a b, so that means it crosses the y-axis at 0. So I'm going to put a point at the origin. And then it's 1x, so that means it has a slope of 1. So it will run 1 and rise 1. So it will just be a line with a slope of 1 through the origin. Okay, now over here on the last piece for the linear function, it's D and R, that's domain and range. All real numbers, goes forever left and right. All real numbers, goes forever left and right. X-intercept, so that means where does it cross the x-axis?
0,
0,
0.
0, put it as an ordered pair. Y-intercept, bless you, where does it cross the y-axis? 0, 0. Okay, so here's the new stuff. This is what we gotta learn about, end behavior. So those arrows right here, that reads approaches, which means going to. So as x is going to, it's going to be infinity and negative infinities. What we're going to put in these boxes. So as x approaches infinity, that means positive forever to the right. So the farther to the right this line keeps going, remember f of x is the same as y. So the farther to the right it keeps going. What does it keep going up or does it go down? Keeps going up, and that's positive, right? So as x approaches positive infinity, y also approaches positive infinity because it's going right and up. Those are both positives. So we're going to put infinity symbols in those first couple of little blanks there. Well, that's hard to do with this fancy thing. Okay, so now what about if we go to the left on our x? That'd be negative infinity. So what happens the farther to the left this goes? Does y go down or does y go up?
Down.
Down, and that's negative. So it'll be negative infinity.
So if the x is negative, the y is negative.
On a line. On a line.
On a line. So this is-
We're going to go through all of them. That'll be how in behavior works on linear functions. Okay, increasing intervals. Increasing and decreasing, that's when I talk about riding my bike on the graph. So if I jumped on my bike and started pedaling on that line, I'm gonna be increasing forever, right? I'm gonna have to be pedaling uphill the whole time, right? Cause it just keeps going uphill. So you write your increasing interval on that from negative infinity to infinity. It's increasing the whole time. It's always going uphill. Okay, then decreasing is where the line will be going downhill. No, because you read a graph always left or right, just like you read a book. So reading that graph left to right, where is it ever going to go downhill? It's not on this one, is it? So this one doesn't have a decreasing interval, so I'm just going to put not applicable in A. Yep. Learn something new, not even math today. He didn't care.
I thought it just meant none.
Does none has an A in it? Why would that be done? I mean, that's not available was better than none. Alright, so next we got absolute value. Let's see what we know about absolute value now. Ooh. Where's my thing going? There it is. Alright, we already know the parent function of absolute value. F of x is equal to absolute value of x. Just the basic. We know that the graph of that has a vertex at the origin, and both sides would have a slope of 1. So there would be the parent function of our v.
What are we using this one test?
It's part of your notes. I'm trying to help y'all out. You let me. Well, thank you. What's the domain of all those v's?
All real numbers.
All real
The
numbers.
range is y.
No. Y is greater than or equal to 0 on that one.
That's what I thought.
Where does that thing hit the x-axis?
0, 0,
0, 0. How about the y-axis?
0,
0, 0. Okay, now to our new part today, the end behavior. So we're going to fill these in. First off, start off with going positive. So we're
Question.
going to put positive infinity and negative infinity. All right, Kinley, hit me.
On this test, we're gonna have to know what end behavior is.
Uh-huh.
Are you for real?
Uh-huh.
Um,
I'm for real, Miss Jackson.
I don't get it. Are we gonna have a whole lesson of this?
this is our lesson.
We're doing it right now.
May you explain to me when we put a negative?
When we go left or down.
So if it's a line that goes like this, and we negative infinity?
I'm not sure about that. Let's see what we got here. As x goes forever to the right, positive is to the right. What does the y do? So as this keeps going forever to the right, this is the new stuff that y'all are whining about, is this keeps going forever to the right, does my y keep going up, or does my y keep going down?
Up.
Keeps going up. So as x approaches positive infinity, y approaches positive
Excuse the
infinity.
interruption. Do not forget that all senior quotes are due by the end of the day today. If you need a form, please go see Miss Bryant. Don't forget that all senior quotes are due by the end of the day today. Everybody have a great rest of your day.
So if it goes like this, it's a negative, right? Because the y keeps decreasing.
Mm-hmm.
So it'd be the as x would be negative infinity, negative infinity.
Yes, on the one that's going down, yes. Okay, but here we're still going up. So as x goes forever to the left, so x is going forever to the left, is my y going up or is my y going down? It's going up. So these are both approaching positive infinity. Now what Riley was describing would have been an upside down v. Upside down v, they would go down, so these would be negatives. Yes.
It's the absolute value when it's never going to be going down, is it?
Uh-huh, it's got a number. We can reflect it if we put a negative out in front.
Oh, yeah.
All right, so now the increasing and decreasing intervals. So increasing, which one of these legs, I'm gonna call them legs, that's not the real names, I don't think. Which one of these legs, increasing means I'd be riding my bike uphill. Would I be riding my bike from left to right, uphill right here? No. Would I be riding my bike uphill right here? Yes.
Wait,
So-
why wouldn't you be riding uphill now?
Because you read left to right, so right here I'd be going downhill.
Oh.
But now I start going uphill, so at what point did I start going uphill?
Zero.
Zero, so I'm gonna say my increasing happens, and this is all in terms of the x, okay, this is all in terms of the x. It's from 0 to infinity, I'll be going uphill.
My infinity sounds trash.
Sometimes I have a good one, lots of times I have bad ones. Alright, decreasing. Decreasing left to right, I'd be going downhill over here. And remember, these go in numerical order, so forever would come first from negative infinity
To 0.
to 0. Very good.
I can't draw those.
Alright, next we got our favorite quadratics.
Quad.
You hanging? We know the parent function. We wrote it about 5,000 times the last couple of days, haven't we? We know what the graph looks like.
When's our test on this?
Probably Thursday.
Thursday.
We know it's gonna have, the parent function's gonna have the same points as our v, right? But the graph of it should look more like a u.
It should not have a point.
Correctamundo. I bet in my boots that the domain and range are gonna be the same as the v. Riley concurs.
I bet you're right.
Alrighty, y'all think that's good? I think even the x and y intercepts are gonna be the same. Man, these quadratics and v's, parabolas and v's have a lot in common. Hey, how about the end behavior?
It's gonna be the same.
It's doing the same dang thing as the v's, isn't it? So as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity,
Approach positive.
negative, oh, yes, I did write it wrong, thank you. Does this thing got an eraser? I don't know, maybe I'll undo, what the heck is that?
I know.
I thought that was an undo button.
The eraser should be in the top right, is that not?
Top right?
Is that not an eraser?
No, that's like a link to cloud is what it says.
Probably click on the pen like eraser.
Oh, what would happen if I pick the eraser?
Is even the intervals the same? I think they are.
Well, I guess I'm gonna just put a
Just mark
Put
it
like
out
a
and
dash
mark
or
the sign.
something.
scribble on it. Alright, so Riley caught me on that. As x goes to the left forever, it also keeps going up positive infinity forever. Okay, Kinley thinks that the intervals are gonna be the same. I'm betting she's right, because I'm gonna go uphill from the vertex to infinity, right? So 0 to infinity. And then I go downhill. Good, negative infinity to 0.
On the test, if you have like an behavior and it's like 4 of those and they're like, yeah, positive, positive, negative, positive, is it gonna be like 1 point the whole behavior?
I don't know, I'll have to look at it and see, I don't know. I'm not sure yet.
2 points would be good.
The more the better on these ones, right?
If
Here.
you're
Whoa. Calm yourself down.
Make the hard ones 1 point, but easy ones 5.
Alright, so now these next few functions are getting into some we haven't done yet. So parent function for a cubic function.
What was the quadratic one? I didn't even do it.
It was all the same as the absolute value. F of x equals x squared. So cubic is x cubed.
X.
Alright, so it's,
This one gonna go like,
yeah, this one's gonna be a little snake thingy. So if I plug 0 in, the smart thing is lagging. 0, and I cube it, it's still 0. 1 cubed is 1.
2 cubed.
Hold on, yeah, that's where it's gonna happen. -1 cubed is -1, so it kinda looks like it's gonna be a line to start with, but Kinley knows that 2 cubed means 2 times 2 times 2, so that's 8. So that jumps way up. Let's see if I can count up from here, 8. 1, 2, 3, 4, 5, I'm off.
Is it the very top?
That's the top line is 8,
Yeah, it's the top one.
so there's 1, 2. Okay, so -2 would be -8. Okay, so you can see now, in order for me to connect through that, it's gonna make a snake. That's what I call that. Could be a lightning bolt. This lagging that's happening with this marker is not convenient. So it's gonna go, come on, try harder. It's gonna be going up, 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 up. It's gotta hang right through those points, then hang left, go up, 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 up. Now, you can plug that in your graphing calculator to get a better picture of it. Mine's not horrible considering this thing doesn't work with not a smart product. I've just got a PDF up there, not a smart product. But you can plug it in your graphing calculator, just like the other ones that we did, if you wanna see a pretty picture of it. Okay. It is cool, I like it on those calculators. So what about domain? It kinda looks like it's going straight up and straight down,
It's all real numbers.
but it's actually inching out a little bit. Riley's right, so it is all real numbers.
And since the range goes past all of this, it's
Range is also up and down forever, all real numbers.
and the y-intercept is gonna be 0, 0.
Okay. Days Riley wants to do something, he is good.
Oh, wait, why is the. Oh, just kidding.
Y-intercept
Just
0,
kidding.
0.
Oh,
It's a positive.
Alright, let me put my positive and negative here and then we'll look and see. Okay, so the farther to the right this thing goes, what does it do up and down?
It goes up.
Goes up, and up is positive. So as x approaches positive infinity,
It's gonna be
y also approaches positive infinity. The farther left this thing goes, what does it do up and down? It goes down, so we finally got a different one here. So as x approaches negative infinity, y approaches negative infinity.
increasing intervals.
Okay, increasing and decreasing is when I'm gonna ride my bike.
0 is it.
So increasing, if I jumped on my bike on this one, riding it left to right,
That'd be a good ride.
it'd be a tough as heck ride. I'm gonna have to be going uphill the whole time, aren't I?
No, you can go downhill.
Where?
Oh, just kidding. We read left to right.
Right.
We're not looking up and down.
Because
That's
it's
right.
a
So this would be increasing everywhere from negative infinity to infinity. Okay, now common sense here, gang. If I'm increasing everywhere, where am I decreasing? You're not. So we got another none. I mean, non-applicable or not available. Okay, we're on to the back page
I have a question.
This
Why,
looks like
why
a
are we
bunch of
putting in
crap.
decreasing?
because it's never going downhill. There you go. Okay.
Square root.
Square root graph is a strange little fellow.
Is it x squared?
No, x squared is a quadratic.
This is a little check mark along.
So our
Oh, yeah.
parent function will be f of x equals
Just
the square root of x.
We've never heard of these,
Well, that's good.
and we're gonna have them on our tests.
You're not gonna have to
We're
do any
gonna
work
learn-
with it. You're just gonna have to know what is in
Oh,
behavior
and
and
we
stuff.
have-
Yeah. See? Yo, you don't
And
trust
if we
me
do-
sometimes.
Yeah,
Really?
sometimes no.
Yeah,
Just
that's okay.
kidding.
We
No,
can learn
it's
how to
kidding.
do it.
Alright, so a square root graph is a strange little fella because square root, if I take the square root of a number until we learn about imaginaries, which we will in the next unit, it's all gotta be positive. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, they all gotta be positives. So if I square root 0, I'd be right here, 0, 0. If I square root 1, I'd be right there.
What is the square root of 12?
It's square root of 12 does not have a perfect square.
But like once you get to 2, they're in the square root of 2.
There's not a perfect square, right? So it ends up making a curve like that. Now you can type that in your calculator and look at it, get a better picture. Summer did that on the last one, they look cool. What it actually is, it's kind of half of a parabola, but it's pointing sideways. Can you see that? Kind of a U, half of the U, but it's pointing sideways.
Oh, yeah.
It would not
I
be
can
all
see
the
it.
numbers, right?
The domain is not all real numbers, you're correct. So this domain goes forever to the right,
But it doesn't go.
but it stops there at 0. So how would we describe that?
It'd be y is less than.
Y, well, domain is X.
Wouldn't it be like 0 something
Okay,
X?
but how have we been writing the ranges all along? We've been saying y is greater than or y is less than?
It's x is greater than 0.
Greater than or equal to 0. Very good.
I thought that when you had something like that, you like, oh, just kidding, that's if you have 2.
Now you could, if you put from 0 to infinity, that's correct. But I'm just trying to get us all consistent in how we write stuff. Okay, what about the range here? Is it going down anywhere forever? No, stops at 0. Does it go up forever? Yep, so y is the range.
Y is greater than.
You got it.
I'll put it on the right one.
Okie our intercepts.
X intercept is 0, 0. And the y intercept is there's in A.
0, 0.
Y, oh, yeah, it's 0.
Mhm.
It'd be positive.
Okay, so the farther I go to the right, do I go up or do I go down? Up, which is positive infinity. So as x approaches positive infinity, y approaches positive infinity. Okay, now this might be weird to you. I wrote negative infinity there ahead of time, but I shouldn't have. I've just gotten in the habit of writing that. This is not going to go towards negative infinity. What's the farthest left is
0.
so it's going to be as x approaches 0. So that one will have a 0. So the closer I get to 0, does my y go up or does my y go down?
It goes up, down.
So it's also, but it's not ever going to go below, right? So it's also just approaching 0. Because this thing ends over here at 0,
Square
0.
roots are always going to end in 0 unless it's a negative.
Unless we're going to, the parent function, yes. We're going to learn how to transform them. We could move them places like we did with the v's and the u's. Alrighty, so increasing interval, I'd be writing uphill from 0 to infinity. Where am I going to ride downhill?
You're not.
You don't.
It's in A.
In A.
It seems pretty easy.
It is, it is, it is.
We have a whole worksheet on it.
There's a homework for it. Alright, so the parent function of a cube root, f of x is equal to the cube root of x. It just puts a little 3 out there in the index for cube root. Okay, its graph is like the cubic on the front page. The x cubed made a snake going, it was real tall. This one's going to make a snake that's more horizontal. So it's going to go through the origin, 0, the cube root of 0 is 0, and then the cube root of 1 is 1. Same thing, negative. But then it's going to be going like that. The snake is more laying down. Plug that in your calculator, get some straighter lines than mine.
Oh, what the heck?
What's the matter?
I just can't write.
Oh, Kinley. Kinley.
I wrote this wrong.
Oh my goodness. Kinley, here.
It's like my brain is just not there today.
Alright, what's the domain?
How do you
All real numbers.
All real numbers. What's the range? All real numbers. So see, even though we've never seen a graph like that before, we know the characteristics about it. What is the x-intercept?
0, 0.
0, 0. What's the y-intercept?
0,
0,
0.
0. As x goes forever to the right, positive infinity, what does y do?
It goes negative.
No, it's going up. As we go to the right, it's going up. As x goes forever to the left, what does y do? Down, so negative infinity to negative infinity. Increasing intervals, am I gonna be riding my bike uphill anywhere?
The whole time.
Yes, the whole time, very good, so from negative infinity to infinity. So if I'm riding my bike uphill the whole time, I don't ever get it downhill, so we got another not available.
Increasing, it's gonna be infinity.
I thought that was okay. I cannot speak apparently. I want and was not available until
Yeah. Some people say applicable, some people say applicable. I tried to ask, one time Miss Kinley was talking, and she said something's not applicable, and I said, what do you use, applicable versus applicable? And she just kinda blew me off, so I don't know. Figured she'd know that's something a GT person would know, not a math person. Why is that stupid clock at work?
That's a stupid clock when speaking away.
I never even knew that was an option to put that up there, well, maybe if I click on that.
Go down there and click
I,
it.
I kid. Oops, so left, lost reciprocal.
Is there a razor at the bottom?
Yeah, you got a reciprocal.
It's been tired.
I think your eraser might be on that bottom bar.
Let's see.
Yeah, well, I'm right, and you're
I
wrong.
don't know what a hand does. Maybe it gives us free high fives. Oh, I don't really know.
So highlight over it. See what
Alright,
it looks
reciprocal f of x is equal to 1 over x. Somebody had one of these on their calculator the other day and they showed it to me and they were pretty impressed. It actually makes, was that you, Kelly?
What?
Oh, you started laughing, I thought it was you. This
It
actually,
was me, but
Oh.
I wasn't laughing at you.
this actually makes a graph that's called a hyperbola. So there's gonna be a big curve in quadrant 1 that gets super duper close to the axes but doesn't touch it. That was not very good. Look, type that in your calculator so you can look at it. And then there's gonna be one down here too.
Mine shows it touches both.
It looks like it touches both, but our calculators, even though these are high-tech fancy ones, they don't have, the best, I mean, it looks like it touches them, yeah, but it really doesn't. If we had a NASA size microscope, it wouldn't touch it.
Did you say 1 over x?
Yeah.
Oh, it's staying or something.
Okay,
like.
did
This
y'all,
one would be
Got
not
it.
over
It doesn't touch.
right, it looks like it,
And it
it's,
would have no
it's
y.
close.
It would have no y-intercept and no y.
okay, so let's go through domain. It's not all real numbers.
It's x is greater than
I'll have to show it to you.
1.
Okay, what about the other way?
X is less.
Okay, so what's the only point on the x-axis that this funny-looking graph does not touch? 0. So we can say our domain, good Kira, is everything except, put a slash through your equal sign, except 0. That means not equal to. So your domain can be anything except 0.
I know, I'm wrong.
Okay, what about your range? It goes up forever, it goes down forever, but there's one point up and down it does not touch. So again, y is not equal
And my
to
x and y-intercept is going to be
0. Very good, little Riley. It does not have an x-intercept or a y-intercept, so we get NAs on both of those.
not. How do you say applicable?
You just did.
This is what I've got myself.
Alright, so as x goes forever to the right, what does y do? So look at this right here. This is my x going forever to the right. Look at your calculator. It's got a better picture than mine does. What is y getting super duper close to? What's y approaching? It's going down, but it's not going to go down forever. Riley's right. What's the lowest it's going to go down to? 0.
Wait, how come?
Because this
Hey,
curve
and
is
we-
going to,
And we do have a decreasing one.
this curve is going to keep getting closer and closer and closer to 0, but never touch it. It's not going to go below it, so we can't say negative infinity.
So it couldn't touch it ever?
Nope.
If the
And
graph
that's
is bigger,
that's called an asymptote when you approach something but don't touch it.
what if the graph is bigger? And it would just keep on going.
All right, as x approaches negative infinity, It's also 0. Very good, Jalen.
Can you explain that to me a little bit more? I'm sorry.
That's okay.
But like, if
Do you have it, do you have it on there or not? It's okay, okay, that's okay. Well,
I should. Yeah.
does she? I'll go up here. Okay, so the farther we go to the right, that's what our positive infinity means, we go to the right. It's not going up. It is gonna keep going down to a point. It's not gonna go down forever, because it's never gonna touch that line. That line is at 0. So we can't say it's going to negative infinity, because it's just gonna go down.
It's going
until
straight
it
like
gets-
that. It's
right.
not pointing like
Right.
Yeah.
It's like it levels out at 0.
Okay, I get that. How come it's not what's going up? Like the line? Cause it's this one as X approaches.
Negative infinity?
I think.
Yeah, when you go to the left, yeah. Alright, increasing intervals. Is there anywhere left to right? I'd be writing,
Oh, we have a one on the bottom too.
is there anywhere left to right? I'd be writing my back uphill.
No.
No, so I don't have any increasing. Okay, what about downhill? Is there anywhere I'd be writing downhill? Okay, so starting from negative infinity, I'll be going, whoo, hope I got a helmet on. I'll be going pretty sharp downhill there,
That would be
right?
fun.
But that levels off there at 0, doesn't it? Right?
Yeah.
Okay, and then up here I'd be going downhill from 0 to forever.
Yeah,
So
so
you're gonna
0.
write that, you got two different pieces here. You're gonna write that from negative infinity to 0,
But why would it be 0 to negative infinity?
because you read left to right. Negative infinity's on the left. And then your other one, read left to right, the 0 would come first, 0 to infinity. Now, I didn't even realize the word was there. I just told Riley what asymptotes meant. Asymptotes is what you approach but never touch. And so these graphs are going to be approaching that line but never touch it. And they're going to be approaching that line but never touch it. So that's right. You write that as x equals 0 and y equals 0.
This is easy. Super easy.
Thanks. That would be something.
There I go again, hitting that darn clock. So our exponential will be f of x equals 2 to the x. An exponential function means you have an exponent that is a variable.
What? Oh, okay. I was like, what is that? Like,
Okay, and its graph, it's going to be going an exponential growth function we will learn about. It's going to be going real flat like an asymptote over here at the x-axis. And then just all of a sudden, it's going to explode up.
I have a question. How do you put x in your exponential graph? Exponent, x is an exponent. So 2.
And then the exponent key is the one that looks like a rooftop. No, no, push second. Push the, now, put your x, now be graph.
will it be on the x-axis?
It looks like it on those calculators, but no, it doesn't ever touch it. Okay, so domain, obviously from the left forever. Is it gonna keep going to the right forever? Yes, all real numbers. Range, it's gonna keep going up forever, but it's not gonna go down forever. And it's also, like Jalen said, not gonna touch 0. So it's not y is greater than or equal to 0. It's just y is greater than 0.
I have a question.
What you got?
How do we, like, when does it ever not go on forever? When it goes on axis?
When does it ever not go on forever? On the domain?
What would you say?
Say that again.
Yeah. Like, on some of the domains we have x is greater than or equal to 0. Why is it that instead of all our numbers?
Because it doesn't go down forever.
Down?
Or x, if it's greater than or equal to 0, it doesn't go behind, it doesn't go left of 0.
Okay.
So you,
But this one goes both ways, right?
right,
Okay.
Right.
Okay.
you got it. Okay, now I just freehanded mine real quick and didn't look at any points, but a couple of y'all got it on your calculator. Does it have an x-intercept?
One.
No. So NA. Does it have a y-intercept? Does it cross the y-axis? Yes. Look at your table and see it's 0 what? 1. Is that right?
Yep.
Yes, very good.
I was just kind of guessing.
That's all right. Nothing wrong with it.
Hi.
Okay, in behavior, as x approaches positive infinity, what does y do?
Negative.
No, farther we go to the left, we keep going up. I mean, I said left and it's right, dumb butt. Farther I go to the right, I keep going up.
So it's just infinity.
Okay, now as x goes to the left, to negative infinity, the y approaches what? 0. Very good, very good.
Increasing into
Will it ever touch the 0?
No, and that's what an asymptote means. All right, increasing.
increasing into.
I'll be riding my bike uphill the whole time, wouldn't I?
Yeah.
Kind of easier down here, but still a little bit uphill. So negative infinity to infinity. Decreasing then can't happen. Asymptotes.
Wouldn't it be x equals 0, y equals 0?
It's not going to be x equals 0 because that is the y-axis
Or y
and it
equals
crosses
0.
it. But it would be y equals 0. Very good, sir. Talent.
What would x be?
It doesn't have an x-intercept.
Okay, with the.
Mm-hmm.
Okay, I was gonna.
Okay. You just have to get your makeup work. Yeah, no problem. All right, we got one more.
I have a question.
What?
The one above this one was different. We didn't have an x or a y intercept. We put x equals 0 and y equals 0. No.
For the asymptotes, yeah.
But you said if you're trying to intercept, you don't have one.
Don't intercepts and asymptotes are not the same thing. Don't mix those up. I don't know what you mean.
But like you said, we don't have an x. How do we not have an x?
An X what?
You said on the asymptote.
There's right, because this graph is gonna get closer and closer and closer to that line, right? But going up and down, it's crossed over the line, there's nothing stopping it. So it doesn't have, it only approaches one of the lines. It blew past this line.
What if it wasn't on the line? It has to be.
Well, there can be another number instead of y equals 0. When we learn how to transform it, there can be another number. We can scoot it up or down.
One more time. I know it's obvious you want to know something. Why isn't there x equals 0?
Because it goes past 0. X equals 0 would mean that we're talking about the asymptote blank. So x equals 0 would mean it could not touch x equals 0. But it clearly touches x equals 0. So that's not an asymptote, so we didn't put it.
What if it touch x equals
Right here. This line, I didn't move right or left any, so its name is x equals 0. This line is named y equals 0.
Like our end behavior, it says as x approaches negative infinity, it's at the next 0.
Uh-huh.
That's why it's the right?
The asymptote, yep. Oh, all right, we got one more, a crazy logarithmic function.
You should, after we get the x, the function, you should let us do it by ourselves.
I'm not good try. Okay, so our logarithmic says f of x is equal to the log of x.
What is a log?
A log, we're gonna learn, we'll have a whole unit on it, but a log is, like if you look up there on exponential, when the exponent is a variable, we don't yet know how to solve for that. Logarithmic functions were invented to let you do that. So that will let us solve for an exponent that's a variable. Okay, so the graph on this, it's a weird one. It's gonna be over here in quadrant 4 mostly. Some of it will squeak up into quadrant 1. Go ahead and graph it on your calculator.
How would one put the log symbol?
It's over on the far left.
Far left.
Oh, okay, I get it.
Left, left, log.
something like that.
Mine didn't go down like that. Mine just
Does it kinda look like it disappears into the axis maybe? Yeah. That's just because our calculators are not the most high def megapixel things.
I'm so confused how you get them all.
Alright, so Riley's trying to fill them all in now. Give him a second, then I'll start going. The domain is not all real numbers on this one.
Oh, it did.
Alright, I'm gonna go ahead now, Riley. I know that wasn't a lot of time, but we're gonna run out of time if we don't. So domain, it's gonna go forever to the right, but it's not gonna go past 0, so x has to be greater than 0. Range, it is gonna go down forever, and it is gonna go up forever, so all real numbers. X-intercepts.
I need to press that.
Where does it cross the x-axis?
At
0,
1.
Other way, Riley, though, 1, 0, right? Come on, marker. What about the y-axis? It doesn't. Very good. End behavior. As x goes forever to the right, what does y do? Goes up, so positive infinity for infinity. Now, it's not negative infinity on this. X doesn't go to the left forever. What's the farthest left it goes? As x goes close to 0, what does the y do? Down, so negative infinity.
Well, I had it the other way around. I had negative infinity.
Well, but x doesn't approach negative infinity. It says as x approaches, and x doesn't go to negative infinity.
0 approaches negative.
Mm-hmm. Alright, increasing.
I put an infinite in the negative infinity.
Nope.
I still don't understand increasing and decreasing intervals this right. I'll be honest.
So where the section you're going up is increasing and the section you're going down is decreasing. And this one is a tricky one. Because we're gonna wanna say that we're going up down here, right? And we are, just super, super steep. But reading on the x-axis, I'm never gonna go in the negatives. So it's going up on the x's starting at 0.
Should be 0 negative.
So 0 to infinity?
0 to infinity.
And then the next one will be negative infinity.
No, where it's not ever going downhill when you read left or right. So that would be an NA, because it's never going downhill when you read left or right.
Because there is
Can
nothing in that
I
one.
try
Right.
that?
Okay? Now, where on this graph is it getting super close to, but it doesn't touch? Okay, this 0 right here on the y-axis, which its name, as I was just talking with Riley about earlier, is x equals 0.
Oh, I messed up.
I put y.
Say that one more time.
If it's about to touch the x, you put y first. If it's about to touch the y, you put x.
Crazy, huh?
So it's another crazy.
Alright, you got another good note page, so till Monday we'll just do some